Hello everyone and welcome to a new episode of Golang Cafe, and today we are going to talk about JSON Web Tokens. In one of the previous episodes we have seen how to implement a JSON REST API just by using the Go standard library, and today we are going to extend that same REST API and we are going to add a authentication layer for one specific endpoint, and we are going to use the JSON Web Tokens for that. JSON Web Tokens is it's very popular among REST APIs, and specifically if you need to do authentication in your REST APIs and your requests, you need to authenticate users, and it's very popular, it's very useful because it's a stateless mechanisms of authentication. The structure of a JSON Web Token is as follows, and you can see here in the console, you can see that is a single string. This is a real JSON Web Token. It's a very long string, it's quite long string, it's split into three different parts. The first part is an header, then we have a payload, which is a base64 encoded, and then you have a signature. So all of the parts are base64 encoded and separated by dots, as you can see. And the header is effectively a JSON payload, which has been, as I said, the JSON base64 encoded. And the fields in the header are usually what you can see here is an algorithm, which in our case is HS256, and the type, which is JWT. In our case it's always going to be JWT, but it can be other things if you are using a different type of tokens. The algorithms, in terms of algorithms, you can have different types of algorithms. There are three major types of algorithms that you may see in libraries. One of which is the HMAC-based algorithm, which is the one that we're using now, and is the symmetric encryption one, is using the symmetric encryption scheme, where you have only one encryption key, both for creating a token and both for validating a token. So this is useful when, for example, the same entity is creating and validating the token at the same time, so which is true in our case. Then we have another two algorithms, which are at least a class of algorithms, because there is more than just three. At least we have three classes. The other two classes are the RSA and the ECDSA, which are effectively that class of algorithms and class of encryption schemes that use asymmetric encryption, where you have a key pair, you have the well-known private and public key. And that's usually what is the de facto standards, especially when working with production systems, and you have a lot of servers talking to each other, and you have JSON Web Tokens being exchanged. And that's useful for two reasons. And the main reason is because there is not a key exchange going on. You don't have to worry about the key exchange that you may have to worry, because the keys there is not the same key that is used for the signing of the verification, but you have a key for signing and a key for verification. So there is not you don't need to effectively worry about the key exchange and configuration. And then there is another factor, which is the verification of the message sender, effectively, because with the public key encryption you can effectively verify the owner of a message or of a signature. But that's not entirely the case with HS256, because there is no information about the ownership of a signature of encryption key. In our case, we're going to use the HS256 because it's easier, it's simpler for our example, but this doesn't actually impact your implementation. You can use RSA if you want to. It's quite easy to change that. In terms of the payload, the structure of the payload is also a JSON object. You can see here that you have a name, and that's a custom field. That's one of the custom fields that you can have. You can have many custom fields as long as they fit within the JSON object. And then you have some other fields which are part of the standard of JSON Web Tokens. So you will see that you have issue that, which is the time where the token was created. You have not valid before, which is the time that represents the date from when the token will be valid, so will not be valid before that specific date. And then expiration date, which represents the date when the token will expire effectively. The subject is also a specific field defined in JSON Web Token standards, and represents the ID of the subject that is inside the token effectively, so that would be effectively the user ID, for example. There are many other fields that you can add here. You can check the JSON Web Token standards that I will link in the description below. So Once we create the payload, and that's done by the server, by the entity that creates the token, we take the header, we take the payload, we take the signing key, which is the secret key, and then we use this algorithm here to generate signatures out of all of this data. And this signature is what is being added at the end of the token, effectively signing the token and creating authenticity mark for this all string here. Then later on, what we're going to do when verifying the token, the algorithm is going to take the header, is going to take the payload, which can be decoded into JSON easily, is going to take the signature, and is going to run this algorithm to verify that the header and the payload yield the same signature. At least in the case of HS256, that's how it works. So then once we have seen how this specifically works, the JWT works, we can start to implement the authentication into our APIs. We just need to create a new endpoint. So just to recap, our APIs has 3 endpoints right now. It has the list users, it has get user by ID, and it has create user. We want to protect the create user such that only users with a token can create other users in our APIs. The first step that we're going to do is create a new endpoint. We're going to do handle here, as we've done with others. We're going to call this auth. And we have auth h, which is auth handler. Auth h is a new handler that we're going to create. So we're going to do auth handler, and we pass the key, secret key, that we also pass to the user handler, so that can be used to both create and verify the token. And now we're going to do auth handler, which is a struct. So it's the same structure as our user handler, effectively. And the user handler implements the HTTP handler interface, which has the serve HTTP method, which we are going to also implement for our auth handler here. So it's serve HTTP. We can effectively search for that, serve HTTP. We can copy all of that and use the same structure, at least, although it's going to be much simpler for our handler here. So this is going to be auth handler serve HTTP, and we are going to just leave the last one, which is method post. So we want to have a auth endpoint that is going to be only available on post requests, and when we do a post request to that auth endpoint, we're going to have a token handler that is going to allow us to create a new token. So we have auth handler, and then we have token, and then what we're going to have is HTTP response writer, and then we have HTTP request, and then what happens afterwards, so we need to effectively now check user credentials and issue a token, effectively. That's what we need to do. The first step is a request, so we need to parse a request, which has a user and password. We just have a simple struct, we just have a simple object, a simple struct, but you can obviously have more complex structures. This is just for an example. So new decoder, we have r.body decode, and then we're going to decode everything into the request. We have our error, and then this is going to be internal server error, and then we return. So, and then what we need to do, we need to check our credentials. Check credentials. I've created a little helper in order to check the credentials, user and password. So if check credentials returns false, then what happens is that we return unauthorized. It's a little helper that I've created to always return for 1. And this returns as well. So check credentials in your case can be a database call. Usually it's a database call. You can do all your checks. In my example, it's just a simple static checks again a set of variables here, a set of predefined static credentials. So once we have defined that, we can create our token JWT new with claims, sign-in method HS256. We said we're going to use that one. Now we have custom claims. So when using the JSON Web Tokens, I usually like to define my custom claims. You can have standard claims. So the claims is effectively the contents of your payload in the JSON. It's effectively just a map containing key values. But you can define that as a custom struct so that you can add many other information and you can have that well typed. So I'm going to use just going to add a username. You can have usually what we have here is a user ID or user email, such that once you set the user email or the user ID, you can verify that the person that is sending you the token is the owner of that user email, that you already verified in advance that the user is sending the information is the legitimate owner of that user email. And then what we do, we also have an embedded struct which is standard claims, which is the default payload struct that is inside the JWT, and that's what we have seen before. So this is effectively just the timing information, issue that, the issuer, the not before, and the expiration of the token effectively. So that's all information that you need anyways, and that's why we embedded it into the custom claims. So now we have the username coming from the request, and then we have standard claims, JWT standard claims, and then expires at least that's the one that we are interested in. We can have many more, but we're just going to use that one. This is a Unix timestamp, and issuer, just for fun, we can just add a URL for the entity that issued the token effectively. This is useful when having the token and using the token between different entities, between different applications. So if the token is being issued, for example, by the Facebook endpoint or the Google servers and all of that, so you want to have a JWT that is being issued by a different entity, and that's useful for that reason. So once we have defined our claims, we just need to sign the claims, the token effectively, and we can do that by doing token signed string, and we pass the key, and that if there is any errors, we can just then return the errors. Well, we wouldn't want to return the errors because the user doesn't need to know about the errors, but you want to log if there is any errors here effectively. And then you also want to return the final token to the user. And you want to return the final token to the user because effectively what happens is that the user is going to then use the token and is going to pass it to your APIs in the next requests. So now we return unauthorized and we return. And at this point, everything should have gone correctly. So status OK, and we status OK, and then we just write the JSON bytes, which represents the token that we've just created. So here what we've done, we first check the user credentials, and the second step we issue a token. So first we build the token. We create a signature, so we compute the signatures of the token, we encode it to JSON, and we return it to the user. Once we have done that, the next step we need to create a function that is going to allow us to verify the token. And the way that we do that is I'm going to just use an authorizer. I'm going to call it authorizer, which takes our key to verify the token, and that's returning a HTTP handler func basically. A responsive writer and the request, and we're gonna see in a moment why I'm doing that, and because I'm using the authorizer in our handler here. So let's go into our create handler. I want to protect this create operation, and I want to first authorize. I want to pass the key to the authorizer, so that returns a function that takes the responsive writer and the request, and attempts to see if the user is authorized to perform this action, and returns a boolean. If the user is not authorized, it returns false, and so then in this case we're gonna do an authorized return, and that's what we wanted to do. Now we need to implement the function here that is going to do the validation of the token. So we have our response writer, we have our HTTP request, return a boolean. Now we want to parse the token from the request. So just as an example, here I have the comment, the header we are gonna have in our authorization bearer, and then here we're gonna have our token, our JWT effectively. That's how it's usually passed into our REST APIs. So we need to parse the token in this manner. We can have a simple regular expression to match that. Token regular expression, regex must compile, so that we can parse the token very easily from the authorization string in the header. Effectively, we said bearer, and then there is a single space. We want a capturing group, and then is alphanumeric. So if alphanumeric, remember that there is also dots, and there is a dash and the underscores, and one or more occurrences of that header token regular expression. So once we have defined our regular expression, we just basically want to parse the token from this value here, and we are going to do that. We are going to get a matches, so we get header token regular expression find string submatch, and then we need to get the other value authorization. We need to have at least 2 items in the slice, because remember that find string submatch returns the whole string that matches the regular expression, and then returns all the capturing groups. We just have one capturing group, so we need at least 2 of those. If it doesn't, then we return false, and that will trigger the handler to return unauthorized. Once we have our token, what we need to do, we need to attempt to parse the token, and when we do that, we do parse with claims, and that, by the way, will change to based on the library you are using, but pretty much that's the thing, that parse with claims will have a slightly different name, but usually they have the same names, and usually they work all the same way. I will link also all the code so you can check the library that I'm using here. Here now we have, I think, just need to check the code doc. So parse with claims takes the token string, so now we have the raw token that we need to parse back into a Go struct. We have the claims object, so if you have custom claims, you pass custom claims. If you have just a standard map, you pass a standard map, which is actually also a Go struct that is used for standard claims. And then we have a key function, and we're going to see in a moment why the key function is used for, what is used for, and what you need to pass in there. So we said here we need to pass custom claims, and then we have our key func. And the key func has the token, so JWT token, and returns an empty interface and an error. And this represents effectively the key func returns the key that is going to be used to validate the token. In our case, the key is the same key that we have used here, the same key that we are used to sign the token, so we don't need to do anything. In a lot of scenarios, in a lot of other scenarios, when the algorithm is, for example, RSA or ECDSA, and for example the key is specified in the token itself, what we need to do here in this function, we will need to effectively do if algorithm is RSA, retrieve key from token, which is going to be different based on the token that you receive. It's not always the same, and so you cannot always have the same key as we do here, which is much simpler in the HS256. So bear in mind the HS256 is not the standard implementation. Most often than not you will see RSA implementation, but the whole high-level implementation remains the same. It's just going to have a slightly different nuances in terms of the implementation in there. So once we have our token struct, we just need to token claims. We need to attempt to parse and to effectively convert our token claims into our struct custom claims. and then if the conversion doesn't go okay, we just return false. Obviously you want a lot of logging here, because if there is a lot of errors, you're not going to see when and where and why all those errors come up. And also the token returns an error, token.valid. It checks if the token is expired in terms of dates, and otherwise it's true. Here, for example, we can add also a just to see the contents of the token. I think that's enough. Token just to see all the contents of the token. I think that would do pretty much all the job. Here also we'll need to check if algorithm is HS256. I'm gonna do in a moment as well. And let's see now what issues we get. So looks like that we don't have any issues. So let's first see without authentication what we get out of that. So the first step is localhost 8080. We said that the current API just have 3 endpoints. Get users, that's the first one. Get user by ID, that's the second one. And then it's a create user, which is a post request where you have data. And we can add some garbage here because we're gonna get unauthorized, and we get unauthorized in this case, but we want to effectively now get a token. So to get a token, we just do post request. We want to add a content type application JSON data, and then we have the user, which we said is going to be admin, which is hard-coded. So it's what we defined hard-coded, but in your case it's going to be whatever is in the database and whatever you're going to use. 8080 and then auth, and that's our JWT. Let's try with some garbage. Let's see if the auth is working, and then we see unauthorized. So now what we can do is we can effectively just check quickly the contents of that, v64, the code, and then we see the header. Let's see, for example, the payload, and it's going to be pretty much what we defined in our code. We have username admin, and you can imagine that here now we're just having a simple username, but you can have email, you can have user ID, you can have the all users inside the JWT, whatever is best for you, so that you don't have to fetch it out later effectively. And then we have expiration of the token and the issuer, but you can have many other information inside the payload of your token. So now let's try to use this token to create the users again. Here we tried here before, and we said content type again application JSON, and then we need to specify our authorization bearer, and then the token that we want to specify. That's the token that we need to pass, and then the data ID to, and the name is Jane, and HTTP localhost 8080 users, name Jane, and that also dumped all the information about the token. So that's effectively what is coming up out of the token once it's been parsed. As you can see, those are the standard claims. You have audience, that's empty, expires us, that's what we specified, ID is empty, issued at, issuer, that's what we specified, not before is empty, and subject is empty. So those are the default fields in the standard claims in the JWT. No matter what library you use, you have those as optional, and you're going to have those as default claims that you are effectively. I would encourage you to use effectively, because they make easy the debugging and the usage of the JWT standard effectively. So once we have created our user, we can let's try to see if that saved the user in our database users. As you can see, now we have 2 users, and we can retrieve the second users as we see as well. So that seemed effectively to work. And let's see also, I think one of the things that we haven't done is the encryption. I think is is not is encrypting, but we haven't specified a key. So we should specify a key when encrypting, obviously, because now we have an empty key, so anybody could craft a token and could effectively authorize himself. For this specific example, at least for HS256, for SHA-256-bit key, the length is 32 bytes key, or 64 characters effectively. So you can there's a lot of online generators, but you can use the command line, and you can read the 32 bytes from random, and then you can do SHA-SUM, and then you can say 256, and that will generate effectively the key for you. We read 32 bytes from the random, and that will generate the key. And that's just the same. It's just that the signing is going to be, now this time is going to be much more secure than just having an empty string as a key effectively. Yeah, I think that's pretty much it. So we have explored the JWT by using the HS256 algorithm. As I said, there are more complex algorithms that you can use, like the RSA and ECDSA, which are the ones that you usually use when working with many machines and many servers and many applications. But the concepts are exactly the same. In terms of library, I've used this library here. Obviously, I've included code in the description below so that you can use it and check it out. There are many other libraries as well for Go, but that's pretty much it. I think that covers pretty much all the high levels of our exercise. Hope you liked the video, and if you have any questions, just let me know in the comments below. Thanks for watching.